we are probably the only group that's able to provide you with not just the raw feeds, but also all of the process information that comes from your Connect. So this is a huge, obviously, a huge advantage. So apart from getting all of the camera feeds and the processed skeletal feeds, you also get, obviously, the raw audio data that comes from the Connect, and you also get the processed beamforming data that you get from the Connect. Does that make sense? You get the actual raw stream, and you also get the processed information in terms of, is your user here, or is your speaker here, and so on and so forth. So literally from the SDK, this is what you receive, right? And this allows you to sort of plan in terms of how to build your application. So with that, we are ready to sort of step one more layer into actually looking at programming and Connect. But before that, I just want to pause for a second and see if there are any questions. So basically, to summarize, what we've seen so far is we've seen what's on the Connect, what the actual hardware device has, and how the software SDK exposes all of that functionality into your application. Right? The next step now is going to actually see it in action. We're going to be able to write some small pieces of code to understand how to retrieve the raw feeds, how to retrieve the processed skeletal information, and incorporate it into your application. Now, the key thing I also want to mention is all of this, like we saw earlier, is available across a bunch of different languages, across a bunch of different project types. So these could be games that you're building, these could be Windows Forms application, these could be WPF applications. Any type of application that you build on Windows can access all of this, right? So just because we build a particular type of application today, or the samples, build a particular type of application, do not assume those are the only types of apps. You can actually incorporate this in any type of app that you're building. Any type of client app that runs on Windows 7 or Windows 8 can take advantage of all of this. So if there are no questions, I'll go with yes.
How do you get the depth information, right?
Right.
Depth information. How does the information come from? By calculation, the depth, you get the depth information.
Right.
But where's the calculation done? Where is the calculation being done for getting the information?
The depth information. Okay. Yeah. So the calculation is done inside the Connect.
Inside the Connect. So there was some processor or CPU inside.
Yes. So you know the let me step back a little bit. You see these three boards right here, 1, 2, and 3. That has a CPU and processing inside the Connect. So in fact, not just the depth calculation, all of the skeletal tracking that happens frame by frame. A lot of that, especially when it comes to a PC scenario, a lot of the depth calculation, all of that's done there. So what comes into your PC is just basically the raw 3D data that gets calculated. But figuring out if a particular pixel is 1 meter away or 2 meter away, all of that is done inside the Connect. In fact, we'll see some as we go a little further. We'll actually see that for skeletal tracking, for instance, the Connect can only skeletal track 2 people, 2 primary players, in terms of breaking down that player into the different body joints. And that 2 limitation is regardless of whether you connect it to an Xbox or to a PC or any other device, regardless of how fast your PC is, because again, all of that happens inside the Connect. So it's basically a bandwidth of the device and the CPU inside the device and of your PC. So yeah, all of that is inside the Connect. Any other questions? Yes, sir.
Hello.
Yes.
I have one question. Why the resolution of the RGB image is different from the depth map?
Right. That's a great question. So basically, for 2 reasons actually. The RGB, in fact, while I call out the fact that it's 640 by 480, that's the native resolution, but it can also support 1280 by 1024 actually. It can also support a higher resolution. But the highest depth resolution it can support is 320 by 240. And this is because, for two reasons. One, through the product development phase, they actually found that this resolution of 320 by 240 is adequate to give you sort of a high fidelity joint recognition and representation. And two, for the performance characteristic, if you make this any larger, then it sort of exponentially takes up more cycles to process. Because unlike the RGB image, which is just basically what the camera sees is what it sends out, for the depth image, it actually goes through a pipeline, right? It basically takes the scene it's seeing, and then it has to basically go to each pixel and identify how far away that pixel is from the camera. And so if you increase this to say 640 by 480, the amount of pixels and therefore the amount of processing that needs to happen increases exponentially. It's sort of a geometric expansion if you increase the resolution. But in also the fact that in testing they found that because we're dealing with sort of known shapes like human subjects, right? This resolution provides high enough fidelity to distinguish different joints. But you're right, I mean, if this had to be expanded to be able to detect unknown shapes, like random shapes, then we might need a higher resolution display to work with. But because it's a known target, because there's a lot of machine learning work that already went in to look at what looks like a body shape and segment it further, it allows us to work with sort of a slightly lower resolution image and processor. The biggest advantage is speed. It allows us to process it way faster than processing a 640, 480 or a 1280.
May I ask another question?
Yes.
Yeah. So the limited is from the USB broadband or something?
The limit for
Because the resolution, you have reduced the resolution to process all those things.
right, it's a CPU limitation more than a bandwidth limitation.
CPU limitation.
Right.
Yeah. So if the CPU is soon enough, is speedy enough, yeah. So can we parallel to two or more connect together to increase this resolution?
So yes, you could technically you can chain two or more connects. But I am not clear in terms of how that would help us get a higher resolution 3D depth map, because both the connects would still be operating at 320 by 240, and so if they're looking at the exact same identical scene, the feed you would get from both is going to be identical, right? In the cases where we see pairing and chaining of connects happen is when you want to cover a wider angle than what one connect can provide. So say for instance, a connect I think typically has a 120-degree field of view. And if you want to get a 360-degree perspective, I can chain three connects together, one looking here, one looking here, and one looking here, and get a full 360 perspective of the scene. But your perspective's resolution is still going to be 320 by 240, and that's going to be the maximum resolution you can achieve.
Maybe for the use of motion capture, because if you got just one camera,
right,
or one connect, you maybe with some angle from your movement, your point was high. So if you got more than one camera, you can catch all the angle
absolutely, yes,
of your body.
Yes, you're right.
So I think can we do that?
You can absolutely do that. So to your point, if I have one connect like this looking at me,
yeah,
it can only see from here to here. It doesn't know what's happening here. It doesn't know what's happening behind me.
Yeah.
But I can have another connect here and another here, so I can see all of me.
Yeah.
You can absolutely do that.
So from now on, the SDK, Microsoft SDK can do these things right
yes.
now.
The Microsoft SDK, the official SDK, can support connect chaining and can support getting streams in parallel from multiple connects at the same time.
Yeah. How much device the SDK supply support? How much?
How many? That's a good question. In terms of theoretical maximum, I mean, we've never seen anybody use more than 3, just because each connect gives you a
maybe
one.
we can try. I just
Right.
want to know if there have any.
There's no theoretical
limitation.
maximum. It's limited by your USB bandwidth on your PC, because each device has to go in its own USB connector,
Yeah.
and your USB bus on your PC should be able to support all of these. Because this is a pretty high bandwidth device. Especially if you turn on all the streams,
Yeah.
it can get high bandwidth. But as far as I know, there's no theoretical maximum. But we've never seen a case, and maybe those cases will emerge,
Yeah.
where if you're trying to cover a huge stadium or something, for analysis of batting and sports and all that. But we've seen about 3 or 4 connects change at the moment. Basically.
Thanks.
No problem. Thank you. So, any other? Yes, sir.
Because your SDK provide the registration information between these two units, the registration. There can be some disparity and also the resolution.
Right. So the question was, just to make sure I got it right, was the question, does the SDK provide registration information, like
Yeah, like which pixel of this
corresponds to which pixel of this?
and
Absolutely, yes.
some disparity.
Yes, you're right. Because so the question was, does it provide sort of a cross-reference system between your VGA feed and your depth feed? Yes, it does. So there are, and the reason that's a great question is because of the fact that if you look, the VGA camera is here and the depth camera is actually here, and so there's a slight phase shift between the VGA camera and the depth camera. So if you try to overlap your depth camera on top of the VGA camera, you'll find a very small shift. And so the Connect SDK provides a method call that allows you to extract the right pixel from the VGA camera for every corresponding pixel in the depth camera. It also allows you to synchronize the VGA camera and the depth camera. In fact, so let me show you something here. You see, actually, even though we show all the camera as a single packaged box, the fact is that the VGA camera, see it here, the VGA camera actually connects through its own USB connector inside the Connect than the depth camera does. So these are actually, if you think about it, 2 separate cameras. And so what we do to make it easy for you to program applications, we provide information like frame numbers and timestamps that allow you to correlate the image that's coming from the RGB camera with the image that's coming from the depth camera. Because it's almost like having 2 separate cameras connected to your PC and trying to correlate the frames coming from each of those cameras. So yeah, we provide all of that information. I'll make sure to point that out as we start programming the SDK. Absolutely. Thanks for that question. Any other? Yes, sir.
Yeah. Thank you. From my understanding that Connect just provide 3D spatial information of each joint. So my question is that when our object just turn around, when you just has its back facing the camera,
Right.
can this system can tell the difference of the back facing or just front facing the camera?
That's a great question. So the Connect sensor cannot tell the difference between front facing and back facing, because interestingly what happens is, like actually Stuart mentioned, all of the skeletal processing that happens on the depth frame alone, right? And so the depth frame has no notion of whether it's front or back. If it detects a humanoid shape, like like a human shape, like a head and shoulders and hips and all of that, it's going to assume it's a human and do skeletal tracking. So we'll actually, when we write the code, we'll actually see if we can demo this. I could stand with my back to the Connect, and it'll still assume that it's looking at me from a front perspective. And that's a great question, but the reason we haven't supported that is because it started off as a gaming system. There are very few, in fact, I can't even think of a case where you would need, you know, you have your connector and your TV there, and you would need to have your back facing the connector, the TV. Does that make sense? But from a perspective, but no. In all seriousness, from a GUI perspective, it makes sense. You know, spatial awareness is important, but in terms of the current implementation of the Connect, it does not distinguish between front versus back in a humanoid shape.
We're now developing a rehabilitation software to handle this issue, but the rotation of the patient plays an important role. So I'm sorry that because we found that OpenNI stick can tell the difference. They just provide some rotation information.
Absolutely.
Yeah. The second question is that I just found if the patient is just laying down, can just connect, it has a precise detail, still can acquire the joint information precisely.
If okay, so
Just
I
laying
think,
down.
if you want to make a comment, the second part or the first? Like, did you have a comment on the first part?
Oh, rotation.
When the subject is rotated?
Come back.
Okay, so we'll get Stuart's perspective on the rotation aspect, but for a subject actually laying down, it depends. So one of the things we've seen with sort of just playing around with the Connect is it's pretty resilient to what you do after it has tracked you. So for instance, the initial skeletal tracking will only work if it can see 2/3 of you. So from your head to your knees, at least, it needs to be able to see to identify it as a humanoid shape and start tracking joints. Now after that, you can actually, you know, get partially clipped from the frame. So you could basically exit the frame and just have, you know, maybe say your shoulder to your hand showing, and it will still track you. It will still basically give joint information. Because along with the joint position information, it also assigns a probability value in terms of how accurately it thinks the joint is where it says it is. And so if it can see the joint, it will basically assign a probability of 100%. But if it cannot see the joint, it can actually infer where the joint should be based on the other joints it can see, and so it will assign a lower probability. So it can do that pretty well, even when you're not in a standing position, even if you move around a lot. But if you, I want to say if you lie down, it depends on what it can see off you. So for instance, if the Connect's looking and I'm lying down like this, and if all it can see is my right hand side, it'll lose track, obviously. But if I'm lying down, where I can still see, you know, a portion of my head, a portion of my torso, and a portion of my legs, it'll actually go into the track. So that is sort of the point I would make. However, the 3D subsystem will still give you all of the 3D data. So if you find that your application requires a user to be sort of in a non-conventional state, like not standing or not sitting, then it should be, and if you find that, you know, if your application is consistently going to be used by a user being in a particular position, then it's pretty straightforward to actually code it up manually through tracking yourself, because all of the raw streams will keep providing you, even if we cannot do skeletal tracking on it, if that makes sense.
Okay. Before I come here, because we are not sure we can solve it or not. So as for the second question, since the patient just is going to lay down, so
right.
We just lay down the Connect, just have it rotate.
Right. So now, yeah, exactly. I see what you mean. If the Connect's lying down, the patient's lying down, they're on the same plane, and so you can track it. Yes. Yeah, absolutely. Did you wanna? Let me give you my.
Thanks, Krishna. Yeah, I think it's just worth emphasising that we see the Connect technology. Connect technology is in very early days for everybody that's working on this, not only from an application point of view, but also those working on SDKs and so on. So what I want to highlight is that Microsoft's keen to hear your feedback on what features you think are missing today or would enhance your application. So if rotation, for example, rotation detection is important to you for your application, then do let us know, either through the forums, which is a great way. The product group read the forums all the time. They're on there. They're supporting people through the forums. We really want to hear what sort of features that you would like to see in the SDK. Where, in particular, they are software features, and rotation detection might be possible to do by software rather than new hardware. Then those are the things you can imagine that we can prioritize to put on future versions of the SDK. And the more people that ask for that feature, then the more chance that that feature gets included. So I just wanted to emphasize the point. Don't think of the SDK as something that's fixed. It doesn't have something. But it's open, we're open to feedback. We want to hear what you would like to see in the SDK. And while we can't promise to implement the features that you want immediately, it really helps us in understanding what the priority is for the researchers, for the applications, the companies that are thinking of using this. And rotation is a great example of that. We're very early days in the SDK. Everybody's trying to put in as many features as possible, but you tell us what features you would like to see.
Absolutely, yeah. The one other thing I would probably add to that is there's again a very strong community around Connect, and so if a feature actually bubbles up, what we've seen in the past is the community actually take a shot at solving the problem, right? I mean, on top of the official SDK. So you'll actually find a bunch of libraries. In fact, one of the sites that I forgot to show that I wanted to show, apart from the Connect for Windows and the channel line sites, is a site called Codeplex. Are you guys familiar with Codeplex? How many of you are familiar with Codeplex? A few folks, right? Codeplex is basically a shared source. We call it shared source repository. So in all technical purposes, it's like open source repository for Microsoft technology source code, right? So only source code lives on the site. And so what you can do is, if you come into Codeplex and search for Connect, because remember, Codeplex has source code from every technology that we make. But if you search for Connect, you can actually see there's like about 80 projects that's been submitted by the community around Connect, and you can actually see that a bunch of those projects actually are toolkits or libraries. So for instance, there's a Connect toolkit here. Somebody's introduced a toolkit for making the Connect into a mouse cursor and so on and so forth. So like for instance, here's one on using it to control PowerPoint. But the point is, if a certain scenario bubbles up, more likely than not, we'll actually see the community actually get in on it and build a toolkit around it. Or we encourage you to actually take a shot at it and throw it here, and then have the community help you iterate and define it further as well. So yeah, it's one of the advantages of having a sort of nice ecosystem supporting the official SDK. So yeah, definitely. And while we're on the topic, I think one of the ways that personally I would try to solve that problem is if you do Connect chaining. If you have more than one Connect observing the subject, then you can actually, between the two Connects, you can identify when the user actually moves away from one Connect into the other. Because what will happen is the skeletal tracking will actually shift from one Connect to the other. So say for instance, I have a Connect at two Connects at 90-degree angles. When I move away, this will lose skeletal tracking, and the other Connect will gain skeletal tracking capability because it can see me in sort of the front position. And so it is possible to write some custom code to track the user's rotation if you chain multiple Connects. And other option could be if you combine the skeletal tracking feed with the feed coming from the VGA camera, and if you write some basic intelligence to figure out from the VGA camera if what it is seeing. Because what the Connect allows you to do is when it returns the position of a joint, say for instance the joint we care about is the head, right? So the skeletal tracking system will basically return the information of where it thinks the head is. There are certain APIs that allow you to take that information and correspondingly match it to the corresponding pixels in the VGA feed. So what you could potentially do is you could isolate the segment, the head segment alone in the VGA feed, pull that, and if you have some basic intelligence, if you write some code to identify if that's the front of the head or the back side of the head, right? That can give you a sort of a makeshift rotation awareness system with just one Connect instead of chaining multiple Connects. So there's approaches but again, the official SDK as of now is Newport. So, thank you. All right, any other questions, thoughts, comments? Okay, so we have, before break, how much time do we have? 10 minutes? Okay, so that's perfect. So what I'm going to do in the next 10 minutes, because I think we're going to go on a lunch break and then come back and sort of pick up where we left off. But in 10 minutes, let me do this. Let me show you what you get when you download and install the Connect SDK. So when you download the Connect SDK and install it, it installs it inside the program files folder, inside this folder called Microsoft SDKs, in its own folder that it creates called Connect. So the program files in Microsoft SDKs folder will already be on your computer, and then Connect, when it gets installed, will create this Connect folder and a subfolder for the version number. The latest version now is beta 2, and that's what we're seeing here. And everything in the installer gets expanded here. So the good thing is that the files do not go to multiple places. It all comes and lives here. And in here, you'll basically see all of the things we looked at. You'll actually see the actual drivers for each of the 4 hardware subsystems inside the Connect. So these are actually the device drivers. So that's an important thing. Install the